Assalamu alaikum. Bismillahir Rahmanir Rahim. Today I will discuss about NAT. What is network address translation? It's actually a security purpose technique to use in networking. It is used for security reasons to change one's IP address to another. So I will discuss some topics that are related to this NAT. First of all, we will discuss NAT for IPv4. Then we will discuss IPv4 address spaces. Then what is NAT? How NAT work? We will discuss these. So let's begin the first topic. NAT for IPv4. NAT is a network address translation. What is translation actually? Means in a network, with respect to a network, a translation means from one IP address to another. This is called a translation. You translate this particular IP address to another IP address. That is a translation, network address translation. So it is used in LAN, we can also use it WAN, but now just we are only focused in LAN. So we will discuss it in LAN. So we will configuration part will later come, but first of all we will discuss the little bit on about configuration. In this we configure and verify inside source NAT using static and pools. There are some rules and regulation in NAT. You use pools and static. Some of the things are in static and some of the things are in dynamic network address translation. We will go it from later. So the other topic is NAT IPv4 address spaces. There are some particular address spaces that we use in IPv4. Those are private and public. It's a worldwide technique, or you can say that worldwide number. It is represented a worldwide number that is 19, or you can say RFC 1918, which is represented for private IP addresses. And we actually, what we do, we not route our private IP addresses to a router to our outside of the router. So we will use a public IP address instead of using a private IP address to connect our network to another, to route our message to another network. And NAT provides the translation of private to public address. Public and private addresses to across devices and resources outside of the local network. So these are the spaces that are called private spaces. That is used only inside a LAN, or you can say that in an organization. Or in a premises, which is called a company or a house or a network shop, whatever, we will use just only these private IP addresses for that particular work. And these are divided into classes, which are as mentioned. Class A from 10.0.0.0 to 10.255.255. A /8 is representing that we only use a particular octet in the IP address, which will be the network address, and this is 10.0.0.0. And the class B is the same as it is mentioned, but what is /12? It actually represents some bits from the above of that class A. It is also representing some bits. Bits are actually shaped like an octet. Octet are eight number, or you can say eight binary numbers, which are represented in IP addresses. These binary numbers are divided into four groups, which are like that: 10.0.0.0. These are the octet values. So the /12 represent that how many octet you can use for making your network address, not the router address but the network address. So these are, whenever the slash increases, like from 8 to 12, from 12 to 16, then according to that we divide our octet and we divide our binary numbers. And the real thing is that IPv4 represented into 4 octets. These octets are 8-bit chunks used for IPv addresses. We will discuss that part later. Now come to the NAT. What is NAT? What is NAT actually? The primary use of NAT is to conserve public IPv addresses. What is a public IPv addresses? That everybody can access easily. You can say that it's an internet ISP provided you a particular public IP address where you can route your data, or you can route your message from one place to another. And in your system we only use the private addresses. Why we use the private addresses? Because these are only available for LAN, to use it in a LAN, so that we can differentiate our devices, that where the device actually plays, where the device is working. Is it working in a premises, or is it working globally, or is it working in a particular area? So the private and public IP addresses are, with respect to that, we use the private and public IP addresses. NAT actually allows network to use private addresses internally while translating them into public IPv addresses or address. It's bit difficult, or you can say that bit confusing. How we can use this public and private? Private is actually you are using inside a premises, but when you go to public, it is different. And the NAT provide the main security reason to change the private IP address to public, because if we go from our private IP addresses, might we get hacked from another hacker, we will be compromised, and we couldn't protect our system, and the system will be conquered by an hacker. And with that conquering, he can do whatever he wants to, and whatever purpose he can deal with that, he can do it. So the third point is NAT router operates at the border of the STAP network. STAP network has only one exit point to the internet or WAN. Actually, what is a STAP network? A STAP network is, you can say, a router that is linking a LAN, or you can say that linking a private sector to a public domain, like internet or like WAN. Globally, you can spread your message globally, or you can spread your message from one organization to another organization. So with respect to that, STAP is a gateway, you can say that STAP is a gateway protocol. So the fourth point. What is the fourth point? When a device inside the STAP network needs to communicate with a device outside of its network, the packet is forwarded to the border router, which performs the NAT process, translating internal private IP address to the device to a public or outside routable address. This fourth point is representing, or you can say that explaining what is an stab. A stab actually, you can say that inside a network. Stab network needs to communicate with a stab is a network inside. Stab network is like a can say that a person staying at a room. Three people are staying in a room and working together, and they are not sharing any information outside of that premises. So stab is like that. So let's come how net work actually. Let's come the main point how net work. PC1 wants to communicate with an outside network. With an outside network, web server with public address. This 209.165.201.1. So PC1 sends a packet address to the web server. R2. Let's see. I will end the slideshow, and I have some other things. You can say that it's an animation, or you can say that it's a concept to clarify what is that. So let's say we have a PC1 that is here we have a PC1 and a server that could be a web server, that could be a email server, that could be anything that serves for a particular reason. So PC1 want to communicate with server 0, so it goes from R1 to R2 and R2 to R3. But there is a bit trick in that PC1 when communicates with R1, it will go with the same IP address like it has inside the lane. But when R1 communicates with, or you can say that R1 transfer the message to R2, when R2 receive this message, the R2 will change this message into private to public IP address. We will discuss it later, but let's come to our slide. So how net is working. There are 6 basic points that how a net work. PC1 sends the packet address to the web server. R2 receives the packet and reads the source IPv address to determine if it needs a translation. Yes, the source IPv address, which is our PC, which has sent messages to a web server. So the web server, so what the R2 do, or you can say that the stab network, or you can say that the router that will convert our PC IP address to the public address. It is actually configured through a process in packet tracer. R2 receives the packet and read the source IPv address, and to determine if it needs the translation, it actually want to learn that either this IPv address need a translation or not for the security reason. So R2 adds mapping of the local to global address to a net table. Local addresses are, you can say that, LAN addresses that we use in our premises, but the global addresses are different. Globally operating in outside of that premises. So we use a mapping in R2 like a net table. So R2 send the packet with the translated source address towards the destination. How R2 do it? We will discuss the lab part later in our video. Now we are just focused in theory part. So R2 send the translated source address towards the destination address. the web server responds with the packet addresses to inside the global address. This is the uh, PC1 address. This one is the public translated address as we are using to communicate with web server. So what we did, we translated our private address to a public domain. And these are the PC address is 192.168.10.10 is translated to this IPv4 address. R2 receive the packet with the destination address. This R2 checks the net table and finds an entry for this mapping. When the address is translated, after that R2 receive the packet with the destination address. And R2 checks the net table. What this point is that the web server when receives the message of PC1, the message is translated from private address to public address, and this message 1 is again for confirmation, or you can say that for connectivity. The web server again transmit that message, transmit that received response to R2 with destination address. This one, and 209.165.200.226. R2 checks the NAT table and find an entry for this mapping. R2 uses this information and translate the inside global address as to inside local address, and packet is forwarded towards PC1.